All right. Good morning, everyone. Today we're going to be talking about OOP. Well, what is OOP? What does it stand for? Why we're using it, et cetera, et cetera. Well, OOP stands for Object-Oriented Programming. And I think we all just the people who came from OOP, and I'm sure everybody has heard of this, but technically speaking, when it comes down to coding, everything is essentially an object, right? Everything has properties, everything has attributes, and we want to start getting into this mentality of writing things in reusable block of code, right? Because we want to follow the whole dry concept of do not repeat yourself. So in order to do this, not only do we have functions, but we also have classes, right? And classes have built-in functions and built-in attributes. Those functions that are built into classes are going to be called methods. And we'll see a little bit of a demonstration of all those things here today. So to give a little bit of a real life example or what's in it for you, right? If we think about people who are really into gaming, and we think about a game, or even if we just think about a website and we keep seeing, for example, Instagram, right? And Instagram, every single time we go through a post, we always see the same exact setup. We see a picture, we see a like button, a share button, we see X, Y, and Z for each individual picture or post that we see. And then we see a couple of comments at the bottom. Obviously, that code is not being written over and over and over and over again. Instead, what's happening is there's just one class or one component that's being utilized over and over again for different sets of information. And that's where OOP comes in handy and why we're gonna learn about OOP today. So let's talk a little bit about object-oriented programming. In overview today, we're going to cover intro to object-oriented programming, what are classes, how to create an instance of a class. We're going to talk about the init and the self methods and how they are utilized in reference to a class. And then we're going to talk about instance methods along with Dunder methods. Okay, when it comes to all of these concepts, you will see them in their assessment one, not assignment one, assessment one. Okay, before we continue moving forward. Is there any questions from the class? No questions. Okay, so what is object-oriented programming? Can I get somebody to read this slide, please?
Sure.
I can read it.
Object-oriented
Oh,
programming, OOP, is a programming approach that organizes code around objects, which are representations of real-world entities. It focuses on breaking down complex problems into smaller, manageable pieces called classes that have properties, attributes, and behaviors or methods. By using OOP, we can create reusable code, promote code organization, and simplify problem solving by modeling the relationship between objects.
All right, fantastic. Thank you so much. Okay, so just like this slide says, pretty much everything is an object. So if we think about a dog, right, and we try to create a dog as an instance, every dog has four legs, every dog has a mouth, every dog needs to eat. There's specific methods and behavior. There's specific behaviors that every dog has, and there's specific attributes that every dog has, right? They all have paws, they all should have a collar, X, Y, and Z. So when we go to create a class for a dog, we know that there's a method such as eat, sleep, bark, fetch, hopefully, if you taught your dog how to fetch, right? And then there's specific attributes that we can give them, as in their paws, their height, their weight. Some things may be common across every single instance, so we don't need to necessarily specify it. And some things we may have to specify, such as color, the height, the weight, if they're sick, if they're not sick, X, Y, and Z, right? So now, what is a class in Python? Well, in object-oriented programming, think of a class as a blueprint, right? We can think about what a dog is or what a dog has, but just because we have the structure of what a dog is, doesn't mean that the dog necessarily exists just yet, right? So a class is just essentially a blueprint. It's me drawing out what exactly something is supposed to have. So here we have a nice dandy picture of an iPhone. I'm not sure if that blueprint is actually accurate. I got it off Google. I thought it looked cool, so I put it there. And then the next thing we have is, we talk about different things about OOP, such as encapsulate data, right? Which is it holds specific attributes, and then it has behaviors, which are methods that operate on that data. Okay, so what is a class instance in Python? All right, so we have a difference between a class. A class is just a blueprint, something that we can use to create different objects over and over again. And then an instance is the actual object being created. So we have a blueprint of what a phone is supposed to be like, of what's supposed to go into a phone. And an instance is once we actually put the materials into creating that phone. Does anyone have any questions up to this part? All right. So now let's talk about the 4 pillars of OOP. So we have encapsulation, abstraction, inheritance, and polymorphism. And sorry, polymorphism. And let me make sure I don't. Okay, so I do have a slide for each individual one of them, so I'm not going to cover them just yet. But these are the 4 general pillars that you'll hear of. Every now and then you'll hear about the 5th pillar, but we'll concentrate on the 4 pillars first, and then if it comes up, if we have enough time, we'll talk about the 5th pillar. All right. So now we have encapsulation and abstraction. So what is encapsulation? So encapsulation means that specific data is being restricted, right? It's the user doesn't need to know about it, and there should be only one specific way to be able to access it. So for example, when we talk about the phone, right? When you go to open up your phone, you get all these buttons, you have all this user information that's being exposed to you, but there's a lot of things in the background that your phone is doing that you don't have any control over, right? It's tracking what usage you have, it's tracking what applications you're using, how long you're using them for. It's tracking your battery life, how much battery is being exposed, depending on what application it is that you're using. And you have no control over that. Sure, you could go into the settings and try to manipulate it a little bit, but it's definitely not to the extent of you being able to actually interact with the code or interact with that function and changing its behavior. Well, that's a form of encapsulation. The developers or the engineers who constructed a phone decided you don't need to have that capability. And that's a capability that they need to restrict from you in order for people to not mess things up with the product they're trying to put out. So they restrict it and they call that encapsulation. So now, oh, and that's also a form of abstraction. These two kind of go hand in hand. So we have encapsulation and abstraction. Okay, so now we have inheritance and polymorphism. Polymorphism, sorry, I keep saying that wrong. Now, inheritance. Oh, I have a question. Go ahead, Andrew.
Yeah, sorry, you kind of skipped over abstraction. Could you?
Yeah. So it's not necessarily that I'm skipping over abstraction. It's just that these two go hand in hand, right? So encapsulation is restricting data, while abstraction is hiding specific data from you, to make sure that you can't interact with it at all. Does that make sense?
Yep, thanks.
Of course. All right, so now we have inheritance and polymorphism. So inheritance basically means, and here we can see 2 versions of the iPhone, right? We have I don't even know which versions they are, but essentially the one on the left-hand side is supposed to be an older version, and the one on the right-hand side is supposed to be the newer version. Now, we all seen it, and I think an iPhone is a perfect example of this. Every time a new iPhone comes out, it's essentially the same one as the one prior, except for 1 or 2 minor improvements, right? Now, those 1 or 2 or 3 minor improvements that they put on there is where where it's now a new class. It's now a new instance, right? It's a brand new blueprint that's happening. But they didn't start from scratch. They didn't go back to the drawing board, throw the old one away, and start from scratch. Instead, they grabbed the old one and then just simply added new features into it, or which is a relationship, right? It's still an iPhone. It's just a newer version of the iPhone that has new attributes and new methods. And then polymorphism is just changing how those methods work. So for example, taking a picture, right? A picture still works the same in both phones, but the quality may be different, right? Or maybe, I think there's live photos. I don't know if live photos were always a thing, but let's say live photos weren't always a thing, right? Maybe in the first edition of the iPhone, there wasn't a thing such as live photos. Well, later on in a newer version, they developed a feature where they were able to actually have live photos being taken through an iPhone. And that's a form of polymorphism. It's just changing the behavior of a method. Okay, does anyone have any questions at this point?
Yeah, sorry, I just put it in the chat. Would a GUI be a form of abstraction?
Essentially, yes, right? Because what you're exposing in the GUI is what you want to expose, but there's likely a lot of background information that's being hidden from the user. So I would say yes. Joshua?
Yeah, inheritance and polymorphism, they just seem like the same thing to me. Can you just kind of reiterate or explain the differences?
Yeah, definitely. So inheritance means I'm taking an older version and then I'm just essentially copying and pasting into my next class, right? I still have all of the same attributes. I still have all of the same methods, but they're just in a different class and I'm adding a couple of things to it, right? So that's inheritance, copying and pasting. Now, polymorphism is I copied and pasted this information, but there's this specific method that I needed to work a little bit different in this class. So I'm going to tweak it just a bit so that it does the behavior that I want it to do and not the behavior that it had before. And that's polymorphism. Does that answer your question, Joshua?
Yeah, thank you.
Of course. And then, these are all things that we're talking about in concept, but we're actually going to see some code and be able to understand it in depth. I think tomorrow is all inheritance and polymorphism. Go ahead, Robert.
Yeah, just a quick question. So do all objects will always have all four of these pillars? Or do they sometimes use some of them and not the others?
Yeah, that's a fantastic question. So they're not always going to have all four of these pillars, right? Some objects may use inheritance, some objects may not. Some objects may use inheritance but not use polymorphism. Some objects may use both. These pillars are a way of thinking of how to program in a larger scope, right? So let's say I'm creating a calculator. You all just created a calculator, right? Well, that calculator should have buttons. So there's some attributes in there. And then a newer calculator may just take the old print, and then maybe I could add a couple of methods into it. The point is that the very first calculator that I created might have used a little bit of encapsulation and abstraction, but the second one that I created, that one is actually using inheritance and polymorphism, right? So it's more of thinking of a grander scope of how you can utilize OOP rather than you need to use these four pillars in order to make a class. Does that make sense, Robert?
Yes, it does. Thank you.
Of course. Frank?
I might be getting ahead of everybody here, but I was just looking at like how you create a class in Python, and I was wondering if that would be like the same thing as creating like what you call it, an object prototype in JavaScript.
Yeah, I'll definitely address that question later on in the cohort.
Okay.
All right. Any other questions? Okay, good. Let's go ahead and keep pushing forward then. All right, so we have getters and setters. That's going to be something that we'll talk about later on. Maybe we could go over this slide deck once we get there. Otherwise, it's not really going to make any sense. So let's pause here. We'll take a look at some code. And then after that, we'll go into actually doing some getters and setters. So just like I said, in overview, what we'll be going over, we already went over what and why OOP. We went over the four pillars of OOP, but we'll talk about composition here shortly. And now we're here at the point where we want to talk about creating a class. Well, how does that work, right? We know how to create a function. I can say a function of a dog looks somewhat like this, right? And then that function just says print wolf, right? So there's a function. I could make it work that way, but that's not necessarily what I want. Instead, I want a class because I know there's plenty of dogs that are going to exist. I can create methods for each one of these dogs, and I could give them different attributes. So now instead of saying def for define, I'm going to go ahead and establish a class. And then syntax for classes, the very first letter of every class will always be capitalized. So then I can just say class dog, and that's it, right? Now I can see a class of a dog. Now, I wonder what happens if I go ahead and print that class. Let's take a look at our terminal and see what goes on here. Okay, so now if I go ahead and print this class of dog, we can see that it's giving me this weird object down here. It's telling me, hey, this is from __ main, right? Which is this, I believe it's this file that it's referencing to. It's telling me it's a class, and it's telling me that this file has a class of dog. And it's in this weird error brackets. Well, we're gonna see a more in detail message once we create an instance of this dog class. But this is essentially the syntax for creating a class. Before I continue pushing forward, it's very important that we get our fundamentals down. So I want to make sure there's no questions about how to create a class in general. Does anyone have any questions up to this point? Okay, looks like everyone's pretty silent, so I'm going to assume that I'm doing a fantastic job in explaining this. So let's keep pushing forward then. All right, so we have our class, we have our dog, but currently our class doesn't really do anything. Just like we saw, we were able to print our dog, and our dog doesn't have anything in general. Now, when we go to create a function, let's say that I wanted to give a name to this dog. Well, I would simply pass an argument to the dog saying, hey, this is going to be a name, and now you can return it into a function, right? So I could say something like name, and instead of saying print wolf, I could say print name, right? And that would give me the function. Well, when it goes into a class, we wouldn't pass those arguments in here. Instead, what we would do is we would create something called the init method. So now instead of saying pass, I'm going to go ahead and define a method. So remember, a method is just a function, but what turns it into a method is the fact that it's a within a class. I'm going to say init. So now what does this do? All right. Init is short for initialize. So every time this class is created, it's going to run this method to initialize the class. So now what exactly is it that I wanted to do here? Well, the first argument that I want to pass into the init method every single time is going to be self. So now the question is, what is self, right? Why do we have that argument? Well, self is it in reference to the class itself, right? So every single time I go to create an instance of this class, self is going to be in reference to the class. Does that make sense to everyone? I can see that being a little confusing. Is there any questions about that?
Yeah, Francisco, I've had a question about this actually. So is there any case where it doesn't reference itself?
Yeah, so there will be later on. Later on, we're going to go ahead and talk about the difference between class attributes and methods and instance attributes and methods. And self is in reference to a class instance, not the class. Does that answer your question, Sean? It may be
Yeah,
so that I can define a little bit better later on.
okay.
Also, just to give everyone a heads up, I don't know if my Zoom is glitching out, but I can't see the timer. So if I run out of time, just send a message on the Zoom chat and I'll see that message so I know to give everyone a break. Joshua?
So self is referencing the instantiated object, like the one that's been created.
Exactly. Yes.
Okay.
Okay. Let's take a look at an example here. So we were just talking about name, right? Well, when I go to create this dog class, I want to make sure that the dog can have a name. And now we can see that self is highlighted, but name isn't, right? And if I hover over here, it's going to tell me, hey, this method of init method is taking in the argument of self at dog. So it's telling me, hey, this is going to be an instance of dog, and it's supposed to take in something called name. And it's saying any, saying that it could take in either string, it could take in a number, it could take in any data structure, but it's going to be assigned of the to the variable of name, the attribute, I apologize, of name. So let's define that. All right, let's go ahead and say self.name is equal to name. So again, self is in reference to the class. All right, so it's telling, hey, the class of dog is going to have an attribute of name, and it's going to be equal to the argument of name when it gets passed in. So now let's go ahead and create a dog. So I'm going to go ahead and have Apollo here. He is a dog and he needs a name. Well, his name is Apollo. Okay, so let me break down the syntax real quick. We have a variable named Apollo. And it's going to be equal to the instance of the class of dog. All right, so the class of dog is being called here. And this init method is being triggered when the class of dog is called. And once the init method gets triggered, it's saying, okay, well, I already know the class that I'm looking for because I'm saying dog. So it doesn't take in an argument for self. And I'm passing into it Apollo. So it knows that the name variable here is going to be Apollo. That name variable then gets passed down into this line 7. And then self says dog has an attribute of name, and that's going to be equal to Apollo. All right. So now when I go ahead and I print Apollo dot name, and we can see that name populates in here. Well, now when I go to run this script, I should see Apollo being printed into my terminal. Now notice that I'm using dot notation. We've seen this in JavaScript, right? JavaScript, when you create an object under the hood, it's essentially creating something like this. It has memory space, it has attributes that you can assign to it, and that's how it's able to use dot notation in JavaScript. Well, in Python, once you create a class, dot notation becomes available because this is a data structure that can actually have attributes in it. So when you do dot, it gives you the different options that belong to this class, right? And it knows that name is the attribute. Now, when I run the script, we can see Apollo is being printed. Does anyone have any questions about this so far? Okay, doesn't seem like there are any questions, so let's go ahead and keep pushing forward. Let's try to give this a little bit, make more sense when we get to the Dunder methods. Okay, so let's go ahead and keep pushing forward a little bit. Let's take a look at a couple of different attributes. Well, we know that Apollo has 4 legs, so let's go ahead and give Apollo 4 legs. We know maybe we can give him a breed. And then that should take in an argument of breed because they're not always going to be the same. And then we could give him a color. All right, and then remember we want to start with self.color. And then this is also going to be an argument, so we could pass in a color. Okay, so now we have a class of dog, has all of these methods. I mean, it has all of these attributes. But now I want to create the dog, right? Well, if I want to create the dog, currently I'm passing in Apollo, and we know that Apollo matches up with name. Self.legs is assigned to 4, but it doesn't take it in as an argument. All right. That's because in my blueprint, I'm saying every dog, this isn't something that you can change, is going to come or be initialized with 4 legs. So now what about breed? All right. How could I give Apollo a breed in line 12?
Make a variable breed
equals dog, and then the breed in quotation marks as a string.
Okay, so then breed in quotation marks as a string. So let's say I'm just gonna do GSD for short. Okay, now what about the color?
You're gonna do the same thing. You're gonna put a string value with separated by a comma.
Okay, so now let's go ahead and say brown. All right, so now let's print Apollo.name and make sure that still works. Okay, that's still working. Well, how do I print the color of Apollo in line 14?
Apollo.color.
So I go to Apollo.color. Now when I run my script, we can see that brown is being printed. All right, if I run legs, we'll see 4. Okay. And then there was something that Anthony said that we need to make sure that we also cover, right? Right now it's assuming that every argument that I'm passing is in order. It's saying, okay, well, you didn't tell me explicitly what Apollo is, so I'm going to assume that Apollo belongs to the first argument, right? Same thing for GSD. The program doesn't know where it's supposed to go, so it's assuming that I'm passing these arguments in order. Well, now what if I wasn't, right? What if I had GSD over here? Right, well, what would happen when I run this? Everything would still work fine, but when I change this into name, it's going to think that its name is GSD because it's just assuming, right? Well, that's where I could actually specify, hey, the breed is equal to GSD, the name is equal to Apollo, and the breed is equal to, oh, sorry, not breed, I apologize, the color, hello. And the color is equal to brown. Well, now when I run it one more time, we can see that the program now is no longer assuming. I'm explicitly telling it where to place these arguments, and it's placing the name of Apollo in the correct attribute. Any questions?
Yeah, I saw when you started, as soon as you started typing breed equals, you got some red squiggles on the others. Does that mean that if you define one, you have to define all, or can you kind of mix and match there?
Yeah, that's a great question. So yes, once you start defining one, the rest to the right will need to be defined as well. Anything to the left will still be assumed that it is in the correct order, but anything to the right will need to be explicitly defined. Does that answer your question, Aaron?
Yep, perfectly. Thank you, sir.
Of course. All right. Well, now we just went over how to pass in this argument, right? But what if I wanted these to have a default value, right? What if we have a someone that we don't know what their breed is? Maybe we could give it an unknown here, right? We could pass in an argument just like we would with a function, right? Where if we didn't know if we wanted it to be optional, I can just pass in a default argument. I could say, okay, well, the breed will be unknown. But notice again, if I specify, I got red squiggles right here on the right-hand side, which means everything to the right of it will also need to be specified. And let's just say brown. So now let's see, we have that breed. Let me change this to breed here. Now, when I run this code and I print Apollo.breed down here on line 14, do we think we'll see unknown, or do you guys think we'll see GSD?
GSD.
GSD, right? Because I'm specifying it. So when I run it, I can see the GSD is what's actually being printed. Now, if I were to remove this argument and I just have name and color, right? Even though the method is looking for 3 different arguments and I'm only passing 2, when I run this, it knows that it has a default value for breed. So instead of complaining and telling me, hey, you're missing an argument and I don't know what to do at this point, It's saying, well, you didn't provide me an argument for it, so I'm just going to go with the default value that's being provided in my init method. And now we can see that unknown is what shows up when I print the breed on line 14. Okay, we just talked a
Same
lot.
thing for-
Oh,
Sorry.
No, go ahead, Anthony.
I was just gonna ask, is that the same thing for like legs? Like you're saying its default is 4, but if you decided to change it where you actually like give Apollo like different information, could you give it 2 legs there and it'll print 2 legs?
Yeah, it's a good question, Anthony. So the way to think about this is anything that is in the initializer method is something that can be changed, right? Any argument that's inside of the init method is something that can be changed. But for example, legs, where I have equals 4, that cannot be changed. When I go to initialize this, I can't say comma legs equals 2, because when I run this, it's going to tell me, hey, legs isn't an argument that's supposed to be passed into the init method, right? It doesn't take it in. It only takes in name, breed, and color. Legs is something that's already set. It's saying this will happen regardless of whatever it is that I want. Maybe later I can create a method that has like, you know, unfortunately, Apollo had an accident. Now he has less legs or something like that. But every instance of a class of dog will always have 4 legs. Does that answer your question, Anthony?
Yes, sir. Thank you.
Of course. Okay, let's go ahead and move on into some methods. So now we have this dog. He's able to do X, Y, or it's able to do X, Y, and Z. All right, where, well, actually, right now it's not able to do anything. All it's able to do is be initialized. Well, what if I wanted to be able to do something like bark, right? Every dog can bark. So maybe we can do DEF, and I'm making a function here. And let's just name this function speak. Okay, well, he's going to be able to speak, but how do I make it speak? Or who is it that's speaking? So now if I just make a function this way, it's not going to register as a method that belongs to the instance. It's going to register as a method that belongs to the class. Sorry, I'm looking at the chat. All right. So instead, what I need to do is make sure that I pass in the argument of self. All right. And this is going to tell it, hey, whenever this is being called, you can only use things that are being that belong to the instance of the class. So now I can just say, well, when this is called, I want it to print. Maybe I want to make this into an F string. Let's say self.name is barking really loud. All right. So now this method of speak is going to print out self.name, which we know is this attribute here on line 7. And then it's going to say is barking really loud. So now if I want to call this method, right, somewhere in my script, I would just say Apollo.speak. Right? And now we can see that this method is being called. And when I run the script, we can see Apollo is barking really loud because it's going to create the class of Apollo. It's going to give him a color and a specific name. And then when I run the method Apollo.speak, it's triggering this print statement, where it's referencing self, which is the instance of Apollo. It's grabbing the name. So it's grabbing Apollo. And then it's saying is barking really loud. And that's how we get this line being printed into our terminal. Does anyone have any questions about this? Pretty straightforward. Everyone good? All right. Looks like everyone's good. So that covers our methods. And now the very last thing that I would like to cover before we go into our break and some exercises is going to be our Dunder methods. So far, we already talked about one Dunder method, and that's the init method here. There's a couple of other ones, and you'll see them. I think we have a link in our lecture. Yes, we do. We have a link in our lecture to a list of different Dunder methods that are available to you. But the main one we'll see here is going to be the string method. So now, the string method is becomes important whenever we go to print or Apollo class, right? Let's say I want to take a look at Apollo and I want to see all the properties or all the attributes that it has, or there's something specific about Apollo that I want to see. Well, when I run this script and I just print the instance of Apollo, I get this really weird string. It's telling me, hey, in the file that we just ran, which is practice.py, it's just representing it as main. There is a class of dog, which we created ourselves. And this class of dog has an instance, but it's calling it an object, right? It has an instance, and then it tells me, and it's located at this weird string. Well, this weird string is actually a location in my memory space. It's saying, hey, there's an instance of the class of dog, and this instance is located here in your memory. And it just has a short version of exactly where it is located in my memory. Right? So that's good. It's at least telling me that the object exists and that it's being saved as long as this file is running. Once the file stops running, it deletes that instance so that it's not occupying more memory space. But it doesn't really tell me anything about Apollo, right? It's telling me that the object exists, but it tells me nothing about the dog instance itself. So let's change that. Right? I'm going to give it another method. It's going to be followed by underscores. And we know that it's going to take in self. Now notice the Dunder method of init had underscores before it, and the Dunder method of str has underscores before it and afterwards as well. So this is telling me that Dunder methods are going to typically be followed and prefaced by 2 underscores. Now, why would somebody do this, right? Why would Python developers or the people who created this language do this? Well, what if later on I want to create a method for this class that's named init, but only init, right? What if I'm creating a robot and that robot needs to have an initialize method? Well, by prefacing everything by 2 underscores, they are basically taking away your ability to overwrite these methods. They're saying, hey, these are essential for the class. So we're going to put 2 underscores before it so that if you want to create it or you want to use a similar named method, you just won't put underscores before it. And then that way it won't interact with the ones we are providing for you. Does that make sense to everyone? Okay, perfect. I see head nods. Okay, so now let's talk about this string method. What is it doing? Why do I need it? Well, this string method is simply just going to return something. And it's going to return an interpolated string, or you could have it return a number, you could have it return whatever it is that you want to represent this class, right? So in my case, I'm going to say self.name is and then I'm going to specify the breed. Or actually, I'm going to specify the color first. So self.color. Okay, so that's going to tell me Apollo is a brown German Shepherd dog. And let's say, and he or it has, and then here I'll say self.legs. Legs. Okay, so now I'm saying that every time I try to print Apollo, rather than printing this memory space, it's going to look for this string method and it's going to say, well, this is the way it wants to be represented. So this is what I'll show in the Python terminal rather than the memory space. So we see before I had the weird memory space where it's telling me, hey, this object, there's an instance of this class at this specific memory location. Well, now that I gave it a string method, it's instead of telling me where the object is located in my memory location, it's saying, hey, this is the way you told me to represent this object. So here you go. Apollo is a brown unknown. All right, it's supposed to say GSD, but it says unknown because we took that off from here. And it has 4 legs. Now, if I wanted to fix that, I can obviously provide the breed one more time. Name it GSD, separated by a comma, and run it. And now we can see Apollo is a brown GSD and it has 4 legs. Does anyone have any questions about the string method? Clarice, are you telling me you have a question? I think I see your hand up.
Yeah.
Okay.
Sorry. Is the string method just to give information about the class, or is it used for something else also?
Yeah, the string method is its only purpose is to show a representation of the class that wouldn't be a memory location. Right? Saying, hey, I don't like the way you're showing me this instance. So instead of showing it to me that way, I want you to utilize the string method to display the class. Does that answer your question, Clarice?
Yeah.
Okay, perfect. What's going on, Eric?
Hey, quick question about the attributes. So I guess the attributes within a class, are they considered like in a global scope?
That's a great question. And no, they are not in a, by global scope, do you mean inside of these other methods?
Like within the class, I can access those attributes within any method, as long as it's inside the class.
Got it. So you can access these attributes within any method that takes in the argument of self, right? As long as it takes in the argument of self, you can access the attributes. The moment you take off the argument of self, it can no longer access the attributes that are being specified in the init method because it has no idea how to reference to them. Does that make sense?
Yes, thank you.
Any other questions?
Hey, Francisco, I just have a quick one. Why would this string method where you print Apollo and it has that output, why would you want to do that?
Yeah, why would I want to do that? Well, let's say that instead of just having a class of dog, right? Maybe I have an array that takes in a ridiculous amount of instances. Maybe I'm running a dog pound, right? And in this dog pound, I'm registering every single dog that I'm bringing in. Well, when I want to see every single dog that's inside of my dog pound, I don't want to see a bunch of memory locations in there, right? Because that doesn't tell me anything about each individual dog. Instead, I would want to utilize a string method so that I can see specific information about each dog within my dog pound. Does that make sense, Robert?
Okay, so it's kind of just like to reference to, like, you call Apollo, if you wanted to know information about Apollo, you would do that so that it would describe Apollo to you, basically.
Right. It's simply just so that it can give me a better description about the object rather than just giving me a memory location.
Okay, got it.
Any other questions?
Yeah, Francisco. So for something like breed, could you create a variable, call it breed1, and then name it Australian Shepherd, pass that into Apollo, and just keep reusing that?
Yeah, so something like breed 1, and then you said to do it Australian Shepherd.
Yeah, something like that.
Okay, hopefully I'm spelling this correctly, and if I'm not, they'll make fun of me. All right. Yeah, it's 2, right? Sheep herd.
No, you had it right.
Okay. Awesome. So then breed 1, and then I pass that in here. That's what you're saying, right?
Yep.
Yeah, you definitely can do that because when it comes down to it, it's just going to look at its representation. So now we can see Apollo is a brown Australian Shepherd and it has 4 legs.
Sweet.
Okay. And then oh, go ahead, Brian.
So kind of piggybacking off of that. So like if you were running a dog shelter and you worked with certain breeds all the time, would it be like, would you maybe want to have a separate class for dog breeds if you, in order to do that, or would it be sufficient to just name the variables of the dogs you typically work with?
I'm sorry, could you say that question one more time?
Well, so like if you had a big dog shelter and you knew you were going to work with a bunch of breeds, would that be a time where you'd want to create an additional class for dog breeds? Or would that be something that or not?
So it specifically the way you are referencing it to me, or the example that you just gave me, rather than creating a class, I would essentially have something in my program that alternates within those specific breeds, right? Where it gives me an option to select within those specific breeds. Now, if there was something that I needed to know about the breeds, like specific descriptions, behaviors, when they're in a good mood or when's the best time to play with them, their energy drive, et cetera, then at that point I would start creating classes because they have attributes and behaviors, right? Whereas if it was just simply different selection of string, then it would just be a function.
Cool. Yeah, that answers what I was trying to get at.
Okay, perfect. All right, let me go ahead. So now that we've gone up to this part of the lecture, that's going to cover portion 1 of our lecture. So for the next 30 minutes, if everyone takes a look into our Code Platoon curriculum, I'm sending the link here on the chat just so that everyone can take a look. You're going to see that under lecture 1, there's 2 assignments. Currently right now it's 10:30. So for the next 30 minutes, I would like everyone to attempt to complete assignment 1, which is app users 1. So right now I'm going to open up breakout rooms. You could all work individually. You could all work as groups, whichever one it is that you would prefer to do. But just give it a jab, start using some of these fundamentals that we just taught, and go ahead and complete app users 1. Once I close the breakout rooms, we'll go ahead and continue on with part 2 of our lecture until lunch. Awesome. Let me go ahead and stop the recording now. Okay, welcome back, everyone. I hope we got some good practice being able to create classes and instantiate those classes. But now we're going to talk about getters and setters. So far, when we talked about attributes and we talked about methods, we went into actually creating those attributes and methods pretty simple, right? And just like we noticed inside of our initializer kind of tells us that it can take anything as an argument, all right? So now that's useful at times, but sometimes we want specific rules to be able to apply to our getters and setters. And that's where getters and setters comes in. We want to make sure that we tell a class, hey, this is the only way that you can access this class, and this is the only way that you can assign a new value to an attribute of a class. Now, in order to utilize getters and setters, we'll have to use something called decorators. Now, decorators are a pretty, I don't want to call it advanced, but it's a pretty complex topic. So we're going to keep it really simple for today. And think of a decorator as in simplistic terms, all it's going to do is it's going to take an argument or a function as an argument, and it's going to alter its behavior. Now, there's a couple of built-in decorators that come from Python, one of those being getters and setters. You'll see other decorators kind of throughout our cohort or throughout our program, especially once we start talking about Django. You'll see a variety of different imports and decorators throughout all of our Django curriculum. But today we're going to try to understand what's going on in the background of a decorator. So a decorator is just going to take in a function, a method, an attribute, and it's going to give it a specific type of behavior. So now, before we go into questions, I think it would be beneficial for us to actually take a look at some code. So let's move on into the code process. So now a decorator. How can I start my own decorator? All right, let's create our own so that we can understand how it works. And then afterwards, we'll go into actually applying these getters and setters in our OOP. So now I'm going to create a decorator by just simply creating a function. I'm just going to call this a decorator. And this decorator is going to take in a function. Now I don't have to actually name this function. I could name this X. I could name this whatever it is that I want. It's just a variable. All right, and all it's going to do is it's going to take in it's going to have a nested function that I could call wrapper, or I could call whatever I want. So in this case, I'll just say nested func. And this nested function, it's not going to take in anything. This nested function is simply just going to print decorator was triggered. Then the actual function will be called. And then we'll go ahead and print decorator is completed. And all this function is going to do is it's going to return my nested function. Okay. So now I created a function called a decorator. This function is going to essentially return the nested function that's nested within it. Now, all it's going to do is it's going to say, hey, I'm going to do this behavior first. Then I'm going to trigger whatever it is that's being passed into me as an argument. And then I'm going to finish up my behavior. Now, that may look a little bit complicated and could be a little bit confusing. But if we take a look at how it's actually being applied, all we would do is call the @ sign, and the @ sign will be what tells us if it's a decorator. So now I'm calling in @decorate a decorator. And I'm just going to say a function. Let's say this function is named greeting. Doesn't take in any arguments. And all it's going to say is print good afternoon. Okay, well now when I print greeting, so if I say, oh, well, they're all print statements. So I guess I would just call the function. So now when I call greeting, greeting is going to access this decorator. And it's going to be passed into as a function. Now this function is going to return that nested function. So the first thing I'll see being printed into my terminal will be decorator was triggered. After that, I'll see the actual function of greeting, which is happening on line 4, and I'll see good afternoon. And then finally, line 5 will be triggered, which is saying the decorator is completed. So now let's run this. Okay, so now I run my code, or I run this file, this script specifically. I see decorator was triggered. That's happening here, where I say @decorator. It's returning this nested function. So I'm saying decorator was triggered. I'm seeing good afternoon, which is happening from line 4. I'm passing in greeting into line 4. And then I see decorator is completed, which is happening in line 5. Does anyone have any questions about how this decorator process works? I must have said function at least 100 times in the last 5 minutes, so I'm going to assume there were questions. What's up, Robert?
Yeah, I'm just a little confused. So on line 4, where you have function there, and that's what's calling your decorator function on line 9.
No. So this here on line 4 is actually calling the function of greeting, right? It's calling the behavior of greeting. So this is what actually triggers this greeting function. So let me see, which in this case, it would be equal to greeting.
And it knows to call that because this @a_decorator here.
Right, so this @_decorator is basically saying that it's going to take in greeting as the argument of func, right there in line 1.
Okay.
Awesome.
Kind of get it.
Yeah, it's really nested. It starts going into this Russian doll of a function within a function within a function. Any other questions? Oh, I see a hand up. Eric?
Yeah, for the at a decorator, the at symbol, how like deep does that go? Like if you were to have another method right under the greeting method, would it also be included? Or does it only call on that one method, if that makes sense?
Yeah, that's a really good question. So let's say we make a function named goodbye, and here we just say, have a good evening. Okay, well now if I go ahead and call that goodbye method, or that goodbye function, I apologize. Let's see what happens. So we see decorator was triggered, which is what we expected. We see the good afternoon, which is happening at greeting, and then the decorator is completed. Okay, so that's done, right? And then we just see have a good evening. So the decorator only applies to the function that follows it immediately after, right? Everything else in the file does not apply to the decorator. I can apply the decorator again. I can say at a decorator and have it happen twice, right? Now we see good afternoon. Oh, sorry, we see decorator was triggered, good afternoon, decorator's completed, and then again, decorator was triggered, have a good evening, decorator's completed. But if I comment it out, it only applies to the function immediately after. Does that answer your question, Eric?
Yes, it does. Thank you.
Of course. Clarice?
I think I'm still a little confused. What is this for? Like, what is it? What's the applications for it?
Yeah, so we're going to see that here shortly in getters and setters. But we need to understand how a decorator works, or the purpose of the decorator. And its purpose is just to simply alter the functionality of an attribute or a method. Does that make sense? I don't know.
Yes.
Yeah.
I suppose.
So for example, right, we have this greeting function that we created, which is just supposed to return good afternoon, right? But instead of it just returning good afternoon, we added this decorator to change its behavior and show me that a decorator was triggered and a decorator was completed, right? So that's all this is doing. It's just saying, hey, I know you have this function, but I already have this built-in stuff that I would like you to add on to this function. And I'm adding it through a decorator on line 8. I see head nods.
Okay, I think I understand. I guess it's one of those polymorphism things.
Kind of. I would say that it's more of a composition relationship than a polymorphism, but we'll get to that later. Awesome. Any other questions? Okay. It seems like we're good with decorators. So now let's actually start applying it to our class. So here we have our dog class, right? And so far, just like we said, our dog has been able to do pretty much anything. Well, what if once we create this dog class, or once it's been instantiated, we, want to put some restrictions on how things should be done? And I think a very good example was the fact of the legs, right? Someone asked me, well, what if we wanted to change the legs? Well, let's create some getters and setters to be able to alter the legs. So now, first of all, if I'm creating getters and setters, is because I want to restrict the way that we can access this information. So now if I want to restrict the way that we can access this information, there's a specific syntax that I have to follow. Now, it's not going to change the accessibility of this information, but it's for other developers to understand, hey, I shouldn't be touching this or interacting with this specific attribute directly. I should be utilizing getters and setters, right? And it's just kind of up to the team and the other developers to follow that standard and those rules. So now all I'm simply going to do is I'm going to kind of mimic this information that we have up here. We have these 2 underscores, and that's to let us know, hey, this is built in. I'm providing this for you. So, don't mess with it. Well, I'm just going to do the same thing for legs, but rather than doing 2, I'm just going to do 1. All right. So now legs is officially something that I'm not supposed to interact with directly. And we can see here on line 13 that self.legs is now not highlighted correctly, right? We see that everything here is light blue, while here self is still light blue, but legs is now white. So it's telling me, hey, this doesn't exist. And if I try running this script, if I try running practice, what just happened? Oh, hold on. We see that there's an error that populates. And this error is saying, hey, you know, you're trying to access this string method that's trying to say, hey, where's .legs at? But .legs doesn't populate, doesn't exist. I don't know what you're talking about. Well, that's where our getters come in. So let's go ahead and create a getter. So now all we're going to do for creating an actual getter is we're going to give it the actual property of at property to let it know, hey, this is supposed to be a property and it's referencing to a getter. So all we're going to do is say at property, and this function is going to be named the actual attribute. So I'm going to call it legs. It's going to take in self, and it's just simply going to return self dot underscore legs. All right, so now instead of interacting with the specific function through self.legs, it's interacting with it through the property value. So now if I run this script, it's going to actually give me the correct information. It's telling me Apollo is a brown Australian Shepherd and it has 4 legs, right? But now instead of grabbing self.legs from the attributes, it's grabbing self.legs from the getter that I created on line 13. Does anyone have any questions about that?
Why would you want to do that instead of just self.underscore legs?
Yeah, so the question was, why would I want to do that? Why would I want to create something like this instead of self.underscore legs? Well, in this example, right, let's say I'm just returning 4 legs. But what if when I interact with it, there's something specific that I want to return? Maybe in here I have I don't just have legs, how many legs there are. Maybe in here I have an array, and that array has dictionaries inside of it that specify each individual leg. And rather than returning each individual leg or returning this entire data structure that I have in here, all I want to return is the count. Well, then I can run the logic for what it is that I want to return and make accessible to the user. This is a form of abstraction, right? I'm trying to hide information or encapsulation. I'm trying to make sure that information that doesn't need to be exposed isn't exposed. And I'm trying to regulate how other developers, including myself or the user, can interact with this attribute. Does that make sense, Anthony?
Yeah, it does. It does.
Okay, perfect. Any other questions? Okay, doesn't seem like there are any other questions. So let's move on to our setter. So now let's say I wanted to set the legs, right? Maybe it's a different form of legs. Well, now, instead of making my property legs, right? I can make my property, instead of having my property just say at property, I can now specify that I'm changing that. So I'm going to say at legs, and that's going to take in the property value as well. And then I'm going to tell it, this is a setter for at legs. So now this is telling my program, if I want to change the value of self.legs, I will do it through the following method. So now my method will say set legs. As soon as I learn how to type again. And then maybe I only want to have an even number of legs, right? Maybe I want it so that it's not possible to have odd number of legs. Well, this is going to take in an argument. So I'm going to say new number of legs. This is a terrible example, and I apologize to everyone. But let's say if new number of legs modulo 2 is equal to 0. So only if it's an even number, and probably less than we also want it to be less than 5. So let's say and new number of legs is less than 5. Then only when those conditions are met do I want self dot underscore legs to be equal to new number of legs. All right, so that's the only way that that will be triggered. So now let's go ahead and actually change the value, right? Currently, right now, my dog has 4 legs. If I go to run this, we can see, okay, yep, Polo has 4 legs. Well, let's put it into practice. Let's say print Apollo dot legs. We see 4. Okay, well, now let's actually change his legs. So now let's say Apollo dot set legs is equal to 2. And now let's print Polo dot legs. Okay, so now we see the values have changed, right? We go to print his legs at first, we have 4. And then when I do set legs, I set it to 2, the value changes, and now it's set to 2. Now, if I try to do something like 3, it's not going to meet the conditions that I specified, so it didn't change the value, right? It left it what it was before, because it's not something that's divisible by 2. If I change it something to 6, it's divisible by 2, but it is greater than 5, so it doesn't change the value as well. So now I have to make it back into 2 in order for it to actually change and make a difference. Now, it's important for us to notice that I'm using self.setter, right? And set legs is a function that takes in an argument, right? Well, even though it's a function that takes in an argument, if I look down here, I'm not calling it as a function, and I'm not passing the argument like I would if it was something like this. Right? And that's because of the setter property. Since it knows it's a setter, it knows that it takes in an argument through an assignment value. So this is how we'll call setters, even though they're written in a functional syntax. Okay, does anyone have any questions about getters or setters and how they work?
I had a question about how when you did the getter method, so when I tried doing it, it just gave as an output instead of the name or breed, it just said like bound method, of main dot dog object at like a bunch of like numbers.
Is your string method still in there?
Yes.
Interesting. Okay, let me go ahead and pause the recording, and then maybe you could share your screen real quick so we can debug it. Okay, awesome. Is there any other questions? Okay, now this is important again because you're going to be interacting with getters and setters the remainder of the OOP module, and your assessment is very heavily reliant on getters and setters. So if anyone has any questions over how to use this, please ask now. What's going on, Brian?
Hey, so I'm just kind of trying to code along with this dog breed example. And I set my property, and then it just doesn't seem to be grabbing that legs. It's giving me the error that the legs of object has no setter, and that because 4 is a constant, it can't change. Is it all right to share?
Yeah, let me go ahead and pause, and then you can share as well. The print statement for calling the setter, I believe you're referencing to this portion. So I call the getter here, which is print.legs. Here I'm calling the setter on line 32. I'm giving it dot set legs, and I'm giving it a specific value to set it to. And then I'm printing by calling the getter one more time so that I can get that value of legs.
All right, thank you.
Of course. Go ahead, Eric.
I have one more question. Scroll up in the code. If we look at line number, I think it's 25,
Mhm.
Or 22 for you, where it has the self.legs. And so what you're doing is essentially is that at property, that's a decorator, right? That's
Mhm.
considered. And so it's taking that and it's essentially, I guess, like looking like syntax wise, it's just kind of like, since you're returning self.legs, it's kind of like pasting. It's like, I don't know how to describe, like verbalize it, but like it's to get that number to pop up. It's like essentially just calling that method, I guess, in that spot in the F string. Okay.
That's correct. Yeah. So it's essentially calling this entire getter. So it's calling this whole lines 12 through 14. And all it's doing is, because it is a property, currently right now, all it's doing is returning the actual attribute, right? Because this doesn't exist unless I create the property for it. And then the same thing for the setter, right? The setter only exists and it's only able to change the value because the property already exists. I can't have a setter without a getter. Does that answer
I
your
got
question?
it. Yes, thank you.
Perfect. Any other questions?
Can you have a getter without a setter?
What was the question again, Clarice? Can I have a getter without a setter? Yes, I can have a getter
Yeah.
and not have a setter. Yes. Go ahead, Matt. Lost you.
I mean, I kind of lost, like, she kind of asked the same question. I was gonna ask pretty much what Clarice just asked, because I guess I'm used to like I never worked with the property tags and stuff. Is that essentially just a way to let the syntax look similar, as if like for line 22 it says self.legs, like that looks like we're just accessing the like instance variable. Do they do that property symbol as a way to just let the syntax look the same, but still let us know like that's private, that legs, but we can still access it? Because
Got
wouldn't just having like another method that just says like return self dot legs do the same thing essentially, and then you would just call it, like it would look differently, but it would do the same thing?
Yeah, and that's a really good observation, right? There's definitely different ways to there's different ways to skin a cat, right? And in this case, the at property value, it gives us the ability to, one, use dot notation to continue to call this method, right? I don't have to put the actual parentheses at the end of it to call it. I'm just calling dot notation so that I can trigger this information. So that's one of the things it gives me, right? There's a couple of other things that the property gives me, the property decorator gives me, but it also gives me the ability to create a specific setter for that property, right? And we see it coming into effect here on line 16, right? When I call the at legs, the only reason why I'm able to do at legs dot setter is because legs is identified as a property. If legs was not identified as a property, this would essentially just be another method. Does that answer your question, Matt?
Yes, it does. Thank you.
Of course. What would be the point of having a getter without a setter? So the point of having a getter without a setter is if you have specific information that you want to display, right? As I mentioned earlier, maybe legs, instead of being a count, it could be a list of dictionaries, right? And each one of those dictionaries holds specific details about that one, but about each individual leg, right? But the user doesn't need to know that, or whoever's using my application or other developers, they don't need to know that information necessarily at this level. So if they don't need to know that information at this level, then I could create a getter that only shows the information that they do need to know, and then hide the other information in maybe some other method where they can actually access it and interact with it. Does that make sense, Andrew?
Yep, that makes sense. Thank you.
Of course. All right. Easy peasy, I see. Everyone's good to go? Okay, so let's go ahead and take the time to just do one more example together as a class. All we're gonna do is maybe we can create, let's say we create a student, right? So let me go ahead and create a file. So here we have a student, and all I want us to do is you guys guide me through it. I'm not really going to give you much of a guidance or instruction. I want you guys to guide me through creating the class of a student. You guys can tell me what attributes that student will have. You can tell me what methods that student will have. And then you guys can tell me how to create getters and setters for specific attributes for that student. And all I'm simply going to do is code whatever it is that you guys want to display on here. So someone go ahead and kick it off.
You're gonna need a
Class.
set class user
Okay, so
for
let's go
student.
class student.
You're gonna need an init. And then what attributes do we want?
Name. Education.
Well, we need
Email.
self too.
Oh yeah, sorry. Email.
Legs.
So that's gonna be something we could change, huh? And then let's just give it ID so that we could have that as well. All right. Okay, so now we have our init method somewhat built out. How do I finish off building my init method? How do I actually set these attributes to the instance?
You do self dot name, self dot education, and so on, and then you'd set the. You can just call them name, education, email, legs, ID. So set, yeah.
Self
So-
dot name, name, self dot education equals education.
Yeah.
All right. Okay, so now we have an init method, we have a class of student. How about we give it a couple of methods? What methods would we want this student to have?
You need your getters.
Okay, well, what are we making getters and setters for? And which ones of these properties is it that we want to make private? Because right now they're all public, right? I don't see any underscores before any of them. So currently right now, all of them are public. So which ones would we like to privatize?
Legs.
Okay. What else?
Email and ID.
Okay, perfect. Email and ID. All right. So that means we need getters and setters for email, legs, and ID, or at the very minimum, getters. So what would we like to do for those?
At property. And then
Def.
just email. Parentheses. Self. And then just return underscore email. Yeah.
Nice. Okay, so that takes care of the getter for email. What about the getters for legs and ID?
Same thing.
All right. Let's see how quickly I can do this actually.
How are you using that super sweet hack?
I am doing Alt or Option, I think. Yeah, I think it's Option. Option, and then you just click on different spots. Wherever it is that you click, it'll make another cursor. That's email, no, that's legs, and there's ID. Legs, subject underscore ID. Okay, so there's our three properties or our three getters. Do we want setters for any of these?
Do.
Did you say no?
For email and ID,
Okay. What do we want to do for a setter for email?
I forgot was it at?
Legs
Add
dot
email
setter.
dot setter.
Yeah,
Okay.
yeah.
And
It
then
would be
def.
def. You can call it like set email. Yeah. Taking in self and then new email. And then whatever-ness we want to filter out if it's a valid email or not.
Yeah. How would we make sure that it's a valid email?
We need to make sure it's a string first, not just some numbers.
Okay. Type email equal to string.
I guess if it includes at something.com, but that could get kind of fancy.
Dude, what the fuck? Oh, sorry.
Your mic is on, Sean.
My bad. My dog just crap dusted me.
You're good.
You could split the
Let's do
screen.
at school.org. How's that?
Yeah, that works.
Okay. So if those two
So
can met what?
if it's all good, then self dot email equals new email.
All right. So there's our student email. And then I think we said we wanted one for ID as well. So how would we go about creating a setter for ID?
At ID dot setter.
At ID dot setter. All right.
Def set ID. Set underscore ID. Self. New ID.
All right. And let's have let's see, let's have someone who hasn't spoken yet start throwing in some collaboration in here.
I'm afraid to unmute now.
You're all good, Sean. I get it. I have my dog's literally right here in his crate, and he does it to me all day. I just resist the facial expressions.
If the length of the ID equals, 8 to make them all uniform compared to other students.
Okay. ID. Okay, so if the length of ID is equal to 8, is that the only restriction you want on there?
What about if it's not a number?
Yeah, it has to start with a letter.
And want it has to start with a letter? Is that what we want?
Sure.
New ID index 0 that is numeric. I think that's right. Hopefully that's right. We'll find out soon. All right. So if those two conditions are met, then we want to change the value of ID, right? How do I do that?
Self underscore
ID
equals new ID.
Okay, so self dot underscore ID is equal to new ID. Okay, so now we have our getters and setters. We have our attributes. Our init method is built out. Okay, this is looking good so far. What about methods? You know, do we want our student to be able to do anything? Representation when I go to print the student, do we want to give them a Dunder string method, or do we just want to see memory space? What would we like now?
Hit them with that Dunder string.
Okay, let's check it out.
It'd be self. And then we could just print f string, each one of the attributes.
Oh boy, I forgot what each one of the attributes are, but let's see. Self dot, I'm assuming name.
Or we could just do a couple to keep it short.
Okay. Self dot ID. Okay, that should be good. Okay, so now we have a Dunder method for the string representation. And now let's just give the student at least one method. All right, what method would we like the student to have?
Add leg.
That's did you say add leg?
Yeah.
Okay, well that would be a setter, not a method. So because we would be changing an attribute. So what method would we like to have?
Present. Oh,
Say again, what was that, Clarice?
I said present, like to be existing. They're present in class or something.
So go to school. Sure. Let's see. Go to school. And then it takes in self, and let's just say it prints I'm going to school. All right.
Or maybe print the name, self dot name and F.
Okay, yeah, we can do that as well. Let's see. F. Oh, self dot name. Okay, so self dot name is going to school. All right, so now we have a class that has attributes. It has an init method. It has getters and setters with private for private attributes. It has a method of going to school, and it has a representation method of a string telling us where it is that they're going. Okay, and I apologize, everyone, but I need to start charging here. All right, so now I have all this information. So let's go ahead and actually put this information to use. How would I go about creating an instance of this class?
Below it, create a variable called student1 equals student with the parentheses with all the data.
Student on is equal to student parentheses, and then you said with all the data. So let's see what data.
Well, we create the data.
Okay, so by data, are you talking about, what are we talking about here?
Our own generated one. So name would be, we could say, Mike, education, high school, then commas, the next one.
Okay.
3 legs, 4 legs, and then ID.
Ooh. We said 3 legs, but I don't think that comes in first. We need an email. So let's just say Mike and I think we went with school.org, right? School.org. Legs, you said 3. And then ID supposed to start with a number. Oh no, it's not supposed to start with a number. So let's go with
Maybe the first letter of his name and then a random number.
okay, first letter of the name and then random number. Let's do that.
Has to equal 8 characters.
Does it have to equal 8 characters? Yes, it does. Okay, so I'll make my life easy. There you go. All right, so now we have our 8 characters. We have its X, Y, and Z. Well, now let's go ahead and instantiate that class. Let's go ahead and print student 1. Okay, so now we can see Mike has been created. Education is high school. The email is mike@school.org. And here we have our ID. Now, let's say we wanted to change the ID, right? Well, how would I go about utilizing the setter for ID to change the value of the ID that we currently have?
Dot set ID equals whatever ID you want. No parentheses.
So just set ID.
Student one dot
Yeah.
set.
Okay, student 1 dot set ID is equal to, and let's give it an invalid value first. Let's say this one. And let's see what it does. Okay, so now when we run it, we can see that when we gave it an invalid value, nothing changed. So now let's meet one condition where the first one goes through. Okay, but it's still not equal to 8 characters. So let's see, we have 1, 2, 3, 4, 5, 6, 7, 8. So I just need to get rid of FS. Oh, that's not what I meant to do. So it met the fact that the length was equal to 8. It's not, is numeric. So string object has no attribute, is numeric. Did you mean is numeric? Of course, I did mean that. There you go. And now we can see that it changed, right? So it went from its original value that we passed up here, gave it a new one, and once it was actually able to met the conditions, we can see that it changed to the second value that we passed into. Okay. So it looks like we were able to build this all together as a class. It looks like everyone has a pretty good grasp now on attributes, getters and setters, methods, Dunder methods, and then each individual method. It looks like everyone's also able to understand the difference between a class and an instance, right? This is all the class that we wrote out here, but it doesn't become an instance until line 39 when we create student 1. Okay. So in overview, today we covered what and why we utilize OOP. We covered the 4 pillars of OOP, except for composition. We will touch that later on. We covered how to create a class, the init method, instance attributes, instance methods, Dunder methods. We covered what are decorators and how they work. And then we covered how to create getters and setters. Does anyone have any questions over anything that we covered today?
Can I see where your Dunder method for self is? Because my code is saying that like I didn't do it properly. It gave me that unique ID.
Are you talking about here?
Yes.
If you're getting unique IDs for each one of these, it's more than likely because you didn't put the @property symbol for one of your setters or getters.
I have all my at properties.
Okay, we could probably debug yours here shortly. Does anyone else have any questions? All right, if there are no other questions, I am more than confident in everyone's abilities to, oh, there it is. What's up, Andrew?
Yeah, so in regards to getters and setters, my understanding is that you're only doing that, you're only creating a getter if you potentially want to change something in the future. Is that correct?
You're creating getters and setters if there are specific standards that you want to apply for an attribute. Meaning, I have all of this information inside of this attribute, but only this is important for people to know. That's where a getter would come in. And a setter is, I only want this value to change if it meets these requirements. Every other attribute can still be manipulated, but getters or setters are a way of enforcing specific rules that you may want to apply to an attribute. Does that make sense, Andrew? Okay, I saw a head nod. I think you said something. All right.
Yep, that makes sense.
Okay. All right. Any other questions? All right. Thank you so much, everyone. Let me go ahead and stop the recording now.